Okay, so for number 3, they say, using a ruler, a pencil, and a pair of compasses, construct the triangle PQR such that PQ equals 9 centimeters, the angle QPR equals 60 degrees, and PR equals 12 centimeters. So, I mean, you could choose however your orientation is, but let's just put PQ as the bottom line. So you could take your ruler and measure out a line that's 9 centimeters. And this is PQ, right? The next thing they're saying is they want the angle QPR to be 60 degrees. So remember, whenever they say an angle and they have like 3 letters, the one in the middle is where the angle is going to be. So in this case, QPR means like it starts at Q, goes to P, and then R. So this angle here, like by the P, is what angle QPR is. And they want that to be 60 degrees. So the next thing we have to do is take our compass and construct that. So I don't have a compass right now, but I'll just explain how you would actually do it with your compass. So the first thing you do is you'd open it a small distance. So maybe like open it where like the metal point would be here and the actual pencil part would be touching the page around here. It doesn't really matter exactly, but just like open it a small amount, right? And then what you're gonna do is you're gonna put the metal point over here, and draw an arc, right? So you put the metal point here, you put the pencil point like around here, or whatever the distance is, and you draw like a little arc, right? Then you're gonna take the compass and don't change the width of it, don't change the distance, but instead of putting the metal point here, over here, you're now gonna put it over here, right? And then draw another arc the other way to intersect, right? And where they intersect, that'll be the line that we're going to connect. That'll give us 60 degrees. So this is just one of the things you have to learn with construction. So yeah, maybe in a future video we could do some revision on constructing different angles and stuff. But yeah, so you'd essentially open your compass a fixed distance, draw one arc, then move it to the other part, draw another arc. Where it intersects, that's what you're going to connect up. So then we want to draw a line through this point and through this point. And that line is going to be PR. That's going to be 12 centimeters. So we're going to take our ruler, make sure we connect those two. And well, you know, this isn't to scale obviously, but this will be 12 centimeters here. That's R. And then you connect this back because it's a triangle with your ruler. And yeah. So of course this side is supposed to be looking a lot longer than this side, but that's the general kind of procedure you could follow to get this question done. Okay, so for this next question, B, they're saying, the diagram below shows two quadrilaterals, R and S, where S is the image of R under a transformation. So we have R and S. So part 1 is saying, describe fully the single transformation that maps quadrilateral R onto quadrilateral S. So it's one transformation that was used. And as you can see, the shape looks basically the same, but just like a bigger version, right? So this is an enlargement, right? And so there are a couple things we'll want to figure out, right? So first, let's write that this is an enlargement. And you can also notice that it's 3 marks. So when this is described fully, you can't just say enlargement. The next thing we're going to figure out is where is the center of enlargement. So one way to do that is to draw some lines connecting the points, right? So this line, if we draw a line here, right? And then we draw another line so that we connected these points, they're like corresponding points. Let's draw a line connecting these. Oh, we can see it intersects there. You could do another one, again, just to be sure. So let's look at these corresponding points. We'll draw another line connecting them. And they all seem to pass through the same point over here. And so that is the center of the enlargement, right? So from there we found it. So and the coordinates of this is 3, 7, as you can see. 3, 7, right? So we could also include center of enlargement. It's 3, 7. And then the last thing we want to figure out, what is the scale of the enlargement? Like, by how much was it enlarged, right? And well, one way to do is just look at the length of each side and see. So this, for example, this bottom line here is 1, 2, 3 blocks long, and in the corresponding shape it's 1, 2, 3, 4, 5, 6. So it's been enlarged by 2, right? You can look at another side just to confirm. This is 1 here, this is 1, 2. So the scale factor is 2. So yeah, that should be enough to give a full description of the transformation for part 1. Okay, so for part 2, they're saying, on the grid on page 12, draw the image of quadrilateral R when it is translated by the vector -4, 5, and name that image T. So this is R over here, and we're translating it by the vector -4, 5. That means -4 in the x direction and 5 in the y direction. So -4 in the x direction means we're going 4 units this way to the left. And then 5 in the y direction means we're going up 5 units. So what you could do is take like any one point. So let's say we're taking this point over here. We're going to apply that translation of -4, 5 to it. So we go -4, so 4 to the left, 1, 2, 3, 4, and then 5 units up, 1, 2, 3, 4, 5. So that's where this new point is going, right? Similarly, this point, we could take it and do the same thing. So we go 1, 2, 3, 4 to the left, 1, 2, 3, 4, 5. So that's where this new point is going, and we'll do the same for the others. Or you could just look relative to these points. Like, we know this point is like 1 below this guy here, so we could just draw him in, and this guy is 3 below. Or you could even map it out with the going 4 to the left and 5 up. Either way, you'll get the same thing, and so you could connect up the lines and you'll get a shape that looks like this. And this is T, they said to name it. So that's part 2. Okay, and so for number 3, they're saying, on the grid on page 12, draw the image of quadrilateral R when it is rotated 180 degrees about the origin. Name the image M. So one thing you could do is you could like look at the points, and you could use a compass for this too, but like visualize it or like trace out rotating it about 180 degrees about the origin. But another thing you could do is you could recognize that a 180 degree transformation about the origin effectively does the same thing as changing the minus signs in front of the coordinates for each point. So for example, if you have a point xy, after you rotate it 180 degrees about the origin, it becomes -x minus y. So for example, this point over here, it's 1, 1 is the coordinates of that. So after translating it, the new coordinates will be -1, -1. Right? Similarly, for this one, it's 2, 1 are the coordinates. Sorry, 1, 2 are the coordinates. So after translating it about the origin, it'll become -1, -2. That's our other point. Then for this one over here, the coordinates are 4, 1. So after the rotation, it'll be -4, -1. And then finally, this one is 4, 4. So that one will become 4, -4, -4. So again, you could like move each point, or you could just, use this little trick. And then, yes, so you draw them out again. So see, I already did this one. That's -1, -1. And the next one, -1, -2. That's over here. The next one is -4, -1. That's over here. And then the last one is -4, -4. So that one is over here. And then we could connect it up. And yeah, so as you can see, that is a 180-degree rotation about the origin. So if you just flip it, you'll get this.